All right, hello geometry students. Today you'll notice that we're actually working on 2 days of surface area. So we had spent 2 days working on surface area of prisms and cylinders, and then we spent 2 days on surface area of cones and pyramids. And today we're gonna wrap it all up before our quiz tomorrow. And today we're gonna be talking about composite figures. So our essential question is, can I find the surface area of composite figures? You probably could figure this all out on your own, but I thought I'd give ourselves some time to look at this together, because surface area, unlike volume, where if I said, hey, find the volume of this composite figure, that would actually be really easy. You just find the two volumes and add them up. But surface area is not that easy. So surface area, if I was to find the whole surface area, it would include this base right here. So if I said I want to cover this whole cylinder in wrapping paper, for example, that would have to be covered. And same thing with this cone. If I said find the surface area of the cone, you would want to include this base. But when I make a composite figure, you are actually going to be subtracting or not using those two bases. So those pieces right here, those need to be subtracted or not included when you are finding the surface area of this 3D composite figure shape. So we're going to do an example. It's going to use these two shapes, and I'm going to show you how you can kind of piece this together in a way where you don't have to do a lot of subtraction or finding other ways to solve it. So our first example, we're just going to have two, is going to be a cone on top of a cylinder. And I'm going to draw this very slowly. And I'm going to put some dots back there to indicate that this is see-through and we can see all the pieces. And so we're trying to draw a picture like this. Our radius for this is 12. Our height is 16, and I'm just going to use units, and then at the end our surface area will be units squared, and our slant height is 8. So not the height, but the slant height, and that's all we need in order to find the surface area. Now I took my formula sheet out of the page protector because it was giving us some glare. So let's really look at these surface area formulas. For example, I want to talk about the cylinder. Let's really dissect what this is. This is 2 pi RH, where 2 pi RH is the L, and L stands for lateral area. And remember, lateral area is all the pieces that are not the base. So in a cylinder, when I cover up the two bases, the lateral area, what you see is the leftover. This curved part is the lateral area. Or the same thing with the cone. If I see a cone, the lateral area is pi RL, which is why when you look at the surface area formula, pi RL, which is the lateral area, plus pi r squared, where pi r squared is the circle, so that would be your base. So we really need to look at these formulas and figure out which parts are we looking for. So let's look here. I'm going to piece this together. I'm going to first find the area of that base. So if I'm looking for the surface area of this shape, I am just simply looking for this amount of space so that I can cover just this with wrapping paper so far. Now, I know how to do this, and hopefully you probably do too, but we can look at our cylinder, and we know that the lateral area is 2 pi RH, and the two bases are 2 pi r squared, so one base is pi r squared, which is pi times 12 squared, which is 144 pi. And I don't want to round yet, so leave your answer just like that before we add everything up. Okay, so the second piece is this whole, I don't know the best, I'm just going to do that. It's like this whole lateral area. So if this is my cylinder, I've only covered up this part, and I need to cover up all of this. And I don't need to piece it together. I know that the lateral area of a cylinder is 2 pi RH, so that's what I'm going to use. 2 pi RH for that lateral, or the circular part of that circumference, of that cylinder, not circumference, is 2 pi 12 times the height, which is 16. So I'm just going to multiply those coefficients out together, and it's 384 pi But again, I'm going to leave it in terms of pi until the very end, so I don't have to round. And then we need to remember that there is not a base between those. If I said, okay, you need to add in, oopsies. You need to add in this base, like you would have to find the whole thing for the cylinder and then add it up. But because I want to find the surface area when those two things are like this, we do not add up those bases. Those bases are not included. So far I have this covered, I have this covered, and the only thing left is the lateral area of the cone. So I can use my formula. I look at my cone and I can either use my surface area and say, well, pi r squared is a circle, so that must be the base. Therefore, pi rl is not the base, or we like to call that the lateral area. So pi r slant height, or pi rl, is up here. This whole like lateral circular area is pi rl, or pi r slant height. I'm just going to triple check, make sure I wrote that down right. Yep. And so we have pi radius slant height. And I'm just going to multiply those coefficients together, and I get 96 pi. So I have officially found all of those pieces together, and I'm just going to add them up. 144 pi, 96 pi, 384 pi. Add those all up, and you get 624 pi units squared. If I would ask you to round that, you'd plug that in your calculator using the pi button, and you would get 1,960.35 units squared if I asked you to round to the nearest hundredth there. So that is how you'd piece it together. I'm going to show another example, so if you're like, hey, I think I get it, I want to move on and try, feel free to stop the video now, but I'm going to do the second example a little bit quicker, a little bit speedier. So we are going to draw this picture where we have this rectangular prism down at the bottom, or it's a square prism, with a square pyramid on top. All right. So start with a square, or I guess a rectangle. It doesn't have to be a square because the bottom is a square. Okay. So now at this point, normally I'd put the top in, but our top is actually a pyramid. So we're going to turn that into a pyramid. Now honestly, I could probably stop there. To make it 3D though, if I wanted to, I could do something like that, keep the pattern going. You want to keep it going like that. Comes down for the square and then up and diagonal for that little pyramid. Oof, that's not great, but we're going to go with it. It looks a little wonky, but we're going to pretend that looks great. So when I am finding the area for a prism, it doesn't have to be a square, but when I'm finding the surface area for a pyramid, I need the base to be a regular shape. And a regular quadrilateral, regular meaning all the same sides, all the same angles, a regular pyramid means that the base would have to be a square. So that's why our base is a square. That's why I'm being picky about it. So it's a regular shape. So my the sides for there are, the sides of the square are 3, but the sides of the pyramid are also 3. So I'm not going to write those up, but you could. The height is 8, or the height for the prism is 8. The height for the pyramid, it's not given, but I will give you the slant height, and the slant height is 6. So that is everything you need to know. Now, same thing with the cylinder. We are going to take out, I'm trying to find the best picture for us. We are going to take out these bases. We don't need these bases. Ugh, it's harder than I thought. So instead of just finding the whole surface area and adding it to the whole surface area, we need to take away 2 of these bases. We need to take that base away and take that base away to add them up. So some people do like to find the whole surface area, find the whole surface area, subtract a base, subtract a base. You could totally do it that way. But I prefer to piece it together, so that's why I'm going to do it. I'm going to find the area of the base down there. Well, the base, oh, sorry, can't even see it. The base of my square, or the base that is the square, the area is 9. Hopefully you figured that out. 3 times 3 It happens to be a square. Then I want to find the lateral area, which is around here, like it's the side or the four sides of my prism. You could find them individually. You could do 3 times 8 plus 3 times 8 plus 3 times 8, but we have a formula for it, and that lateral area is the perimeter times the height. But the perimeter is 3 plus 3 plus 3 plus 3. So you could just piece it all together, or you could use the lateral area formula. Perimeter times height is 12 times 8, which is 96. And then lastly, our lateral area up here. So I'm going to use a different color. Oops. The lateral area up here. It has no base, so when I look at my, oh boy, dropping things. When I look at my formula for a pyramid, my lateral area is 1/2 the perimeter times the slant height, because that B stands for the base. So when I look at this shape and I want to find the surface area that's going to be covered by wrapping paper, for example, I don't want this base. There is no base here, because that's going to attach to the other shape, or the rectangular prism in this case. So 1/2 perimeter times slant height, because that's going to exclude that base, which is what I want. The perimeter we just found, it's 12. The slant height is 6. Figure that all out, and that is 36. So I piece that all together. 9 plus 96 plus 36 is 141. And I forgot units, so unit squared.